so that in case you happen to miss something, right, you think I went too fast, you want to go back and rewatch it, I'm going to go ahead, record it, upload it to YouTube, and I'm going to attach the link to the post for class today, right? That's what I did for all of last week. So remember, if you just scroll down, you wanted to go over one of the lessons, just find whatever the lesson topic was, and you should see a link to a YouTube video for that lesson for the day, all right? That's just another tool to help you guys out with trying to learn this stuff, all right? But what we're going on with today is, remember, we did lesson 1 last week, which was Introduction to Ratios. Today we're going on to talk more about rates. So last week we started this. You guys, during the independent practice time, technically should have already finished this, right? So this is kind of me just going over it in more detail, explaining things. If people have questions, now's your chance to stop and ask me so that I can help you with this stuff, okay? All right, good. Alfie, it's good if you did it already. And then the idea is after I go over it, you guys are going to be working on the mastery test for today. Again, the mastery test, you have 3 attempts. You have to get at least an 80%. So make sure that you understand it before you go on, right? If you already started it last week, right? Let's say you took it once, you got a 60%. You shouldn't just try it again immediately without trying to review something. So just get in the habit, right? If you take it once, you don't pass it, you definitely want to go back, look at the lesson to see if you missed something, or wait until the next day and you can say, hey, Mr. Cray, there was a question like this. I didn't know how to answer it. I can help you out with that, right? I'm not gonna be able to answer any exact questions, but if you say, hey, the question said this, 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 I can say, okay, so the way you would answer a question that's like this is I'll give you a different question and go over how to answer that, okay? And just give me a second, I'm just checking the chat. Okay, good. So, and again, right, we might be going at a slower pace for some people, a faster pace for some people. People are all at different rates. So I'm hearing some people say that they finished it already. If you finished both this and the mastery test, you got over an 80%. That's good. That means that you're already ahead of the game. You're ready to go on to the lesson for tomorrow, though I have it locked because I don't want people moving too fast, just trying to rush through things and not taking their time with things, all right? So if you're done already, just stick around, walk through the lesson, and then you won't have too much to do later on. Okay, but getting into the lesson, we were talking about rates, just really quickly going through those first couple of slides from last week. The objective was to talk about unit rates and using those rates also to find equivalent rates is what this whole lesson is about here, right? So remember, we had this whole scenario talking about tickets for a roller coaster ride. It was 20 tickets for $10. Last week we figured out that means that it had to be 50 cents for each ticket, right? That's a unit rate. We talked about things like miles per hour. Anytime you're talking about per hour, that's actually per one. So 60 miles per 1 hour is an example of a unit rate. And we can use that unit rate, we're going to see later on today, to figure out rates of other things. So if we wanted to say, hey, this car is driving this fast, how far would the car drive in, say, 3 hours? That's something that you can answer once you know how to use the unit rates. Right, so we saw an example with the total cost of tickets. We said if instead of $20 tickets for $10, if it's $12 for 6 tickets to find the cost of just one, you need to divide. But just make sure that the order, usually the price ends up being your numerator and the number of things is your denominator. So you take $12 divided by 6 tickets, that tells you that it's $2 for every single ticket. Right, so we ended last week with you guys working on this section yourself. So you were supposed to find the average ride time for one ticket for all of these. So just before I go on, does anybody have any question for any of these parts here? Let me know before I move on. Right, but again, this part here, you guys should have already done. So right now I'm just gonna take some questions if you have them. I'll wait for about 15 seconds in case anyone has questions. Okay, so just gonna move on, right? So again, we're talking mostly about unit rates. And when we talk in math about the word unit, usually that means we're talking about one thing. So one unit of something, right? In this example that it's giving us right here, it says that Sam can do 36 push-ups per day, right? Now, if it's saying per day, just remember that means per every They're just leaving off the 1 because it's kind of implied there. So thinking about it as a unit rate or a ratio, we usually write that as a fraction. So 36 is the number of push-ups that he can do. 1 is the number of days that it takes him to do it. So 36 over 1, right? That's a unit. 36 push-ups for every day. Now, the idea is that we can use that unit rate to answer a couple of different questions, right? We can figure out how many push-ups he can do in, say, 5 days, how many push-ups he can do in 10 days, how many push-ups he can do in 20 days, right? As long as we know how many he can do in 1 day, we can kind of use that to figure out moving forward how many he's going to do overall, right? So the example that it gives us here is it's talking about how many push-ups can he do in 6 days, right? So, 1 second. Again, we know he does 36 in 1 day. So if we want to figure out how many push-ups he does in 6 days, basically what we do is we scale up this ratio, right? So we started with this ratio that's 36 over 1. So if he's doing it in 6 days, you basically scale up the ratio and multiply the entire ratio by 6, right? So I multiply this by 6, and I also have to multiply the denominator by 6 here because I'm scaling them up at the same rate. So 36 times 6 gives us 216. My pen is very laggy today. All right, I'm not going to use it right now. So 216, that's push-ups in 6 days. That's what this fraction here means. That means that he did 216 push-ups in 6 days. And if I were to divide that, that would take me back to my unit rate of just 36 push-ups for every 1 day, right? And you're going to see some questions on the mastery test that ask you to do things like this. They'll say, okay, you have this rate. If this went on for this amount of time, what would the amount be? So you just have to scale up by multiplying. And if it's a unit rate where you just have 1, that should be pretty simple. Right? Another good example of unit rates that we see, or rates in general, is speed, right? We talked about, I think, that example yesterday of a car that's going 80 miles per hour. How far does it get in 1 hour, right? Good. For speed, we can work backwards and find the unit rate. So if we know that somebody drove 150 miles, and we also know how long it took them to do that, you can work backwards to figure out what your unit rate has to be. So in this example here, again, right, it says that he drove 150 miles. It took 3 hours to do that. So the way that you figure that out, remember, you have to divide 2 things. Just think about the unit. Miles per hour means miles over hours. So it's always going to be the distance divided by how long it took to find that distance, right? Speed is always distance divided by time. That's something you want to try to remember. That's a lot in the future. In math classes, also when you get into science classes, if you ever take a physics course, speed is always distance. And that comes from the units, miles over hours. It's not hours per mile, right? So if we're saying that somebody is going 150 miles in 3 hours, the way that you find that is just by dividing those 2 numbers. You could say 150 miles, the distance, over 3 hours. 150 divided by 3 gets you 50. So 50 miles per every 1 hour would be the example of the unit rate here, right? If you guys have questions as I'm going, just please stop me to let me know, right? This doesn't give you a lot of examples to work off of. So if you don't understand the examples that are here, you just got to make sure you let me know, okay? So it does give you an opportunity to practice it here. It says that Olivia's on a road trip. So we have the amount of time. We know that it's 3 hours. We also know that they traveled 183 miles. So now it's asking us how fast were they driving in miles per hour. Remember, that means miles over hour. So can somebody just tell me how we would go about figuring out the speed of the car here? And it's very similar to the last slide. What do I have to do with the numbers that I see here?
You have to do 183 minus 3.
Minus?
Divided.
Divided, right? So 183 miles divided by 3 hours, right? And that gives us the unit miles over hours, which is miles per hour. When you see this per in math, that really means division. So it's telling you what to do. It's telling you take the miles, divide it by the hours. So a lot of times you can work backwards from the units to figure out what you need to do with the numbers. So if we do 183 divided by 3, does anybody know what we get? So it's going to be the unit rate. What is the unit rate for this example? So don't forget, you have a calculator tool here built right in that you can use, right? The way that I would do this is I would just do some quick mental math. Hopefully this doesn't confuse you, but I would say, okay, I know that 18 divided by 3, I know that's equal to 6. I'm just showing you guys some quick mental math. So if 18 divided by 3 is 6, that means that 180 divided by 3 has to be 60. But I don't want 180, I want 183. So I basically just have 3 extra that's going to go between those. So it's really going to be 61, right? But if that's confusing you, have no idea what I'm doing there, don't worry about it. Just use the calculator, all right? So that should be 61. And when we're doing word problems, units are very important. So 61, what? 61 miles, 61 hours? No, 61 miles per hour, okay? So hopefully that one made some sense. Hopefully you guys were actually able to do that without me helping you there. Because it's very similar to the last one, but if not, that's okay. We saw that example there, right? Another good time when we see unit rates is when you're talking about price, right? So a lot of times you go to the store, maybe you're shopping online, and you have different options when you're buying things, right? So if the only thing you're worried about is cost, unit price is really important. Right? There are a lot of other factors like maybe the brand that you're buying, something might taste better than something else. But in general, you're usually caring about the cost. But it doesn't always give you the unit price. So for this example here, they're saying that you're at a store and it costs $16 to buy 4 dozen apples, right? So if you're trying to price shop, you might actually be more concerned about, okay, how much maybe does it cost for just 1 dozen of apples? That would be an example of a unit rate. So to do that, again, it's almost always going to be your cost divided by the number of things. So $16 divided by 4 tells us it's $4 for 1 dozen apples. That's a unit rate. It's money over apples, or dollars per dozen apples in this case, right? But you guys probably don't go around buying just dozens of apples, but I'm sure lots of people use Amazon, right? You might not necessarily be buying diapers, but this is just an example I wanted to show you, right? So my daughter, she's potty trained right now, so she doesn't actually need diapers, but something that I used to do is would have to go online, order some diapers, and try to figure out what's a better deal, right? So if I'm not really worried about the characters that's on them, and I'm just more worried about the price, let's say I was comparing, say, these diapers right here to the one that's right next to them, right? So I can see some information here. I can see, okay, so this here is 124 diapers, costs $42.73. This one over here is 66 diapers, and it costs $26.91. So I might say, okay, so this one is cheaper, and it comes with less diapers. This one is more expensive. It comes with more diapers, right? But which one here is actually the better deal, right? Math is actually going to help you out here. So if I want to figure out basically how much am I paying for just 1 diaper, again, you pretty much always do the same thing. You're going to take the cost. So in this case, the cost of the entire pack is $42 I divide that by the total number. So in this case here, there's 124 diapers. If I divide that, that's going to give me the cost for just one diaper, and it actually gives it to you here on Amazon. So if you actually look closely right here, you see it says 0.34 per count. That's actually telling us that if I divided this by this, somebody feel free to check it out, you should get that the cost of just one diaper in this case is 34 cents, right? So it sounds pretty cheap. Let's look at the other one. And again, right? It actually gives it to us here. So I can already see that that first one is going to be the better deal. This is what this means here. It's 0.41 out of count is telling us how much it costs for just one. But the way that you would get to this number here is I would, again, take the cost. So it costs $26.91. Divide that cost by the total number of diapers, which is 66, right? So it's always cost divided by the number of things, right? And I could scroll down, right? This one was 34 cents, this one was 41 cents. Again, if you know how to read this, you can just find those numbers yourself, but if you're going to the supermarket, you might not see those numbers there for you, right? And just to look at another example, right? Let's say I might think, okay, let me actually get less diapers. I want to get a smaller pack. I don't want to spend so much money. So if I wanted to get a pack of, say, only 22 diapers, that's going to cost $16.98. But you can actually see that the unit rate, the cost per diaper is actually 77 cents. So I'm spending less money now, but in actuality, I'm actually spending twice as much per diaper than if I was to buy one of these packs up here, right? So that's actually a really bad deal unless you just don't have the money for a big pack, right? But again, you guys probably aren't buying diapers. Does anybody have an example of something that they might buy online that they want me to just check the prices for? Because you can do this with pretty much anything that you're buying, especially if you happen to go to like those big box stores, like say a BJ's or a Target, right? A Switch, that's not really gonna work. I need something that comes with multiple things in the package. Not really a computer either. So something that might come with, 10 of something, 15 of something, and they might come with like different sizes of things. Maybe more for like food or drinks than like computers and stuff. Okay, pens. Sure, let's look at pens. Okay, so we're looking at some pens here. Let's say we stick with these over here, right? Just some regular big pens compared to like, say, this box down here, right? So this box up here, it's $11.93 for 144 pens. So if I want to figure out, okay, how much does it cost for just one of those pens, right? Again, I'm just going to go and say the cost, which is 11.93. Can somebody do the math for me? Divided by the total number of pens, which is 144. So it's going to be pennies. It's going to be a small number. Anybody give me that number quickly? 11.93 divided by 144. All right, I'll just do it quickly. 11.93 divided by 144, it's telling me 0.08, right? So that's going to be roughly 8 cents per pen, right? I'm not going to write the decimal, I'm just going to write 8 cents so it's easier to read. Right, that one's 8 cents. Now, let's say I'm looking at the one at the bottom, same style of pens, kind of, right? But now it's $5.97 for 36 pens. So in this case here, if I was to do the $5.97 divided by 36, let me write it on the side. Let's put some units, that's dollars, divided by 36 pens. That's going to tell me how much it costs for just one of those pens. Let me do that calculation right now. 5.97 divided by 36. So in that case there, this one is actually about almost 17 cents per pen. So the pens here are approximately, oops. All right, we're freaking out here right now. Sorry about that. All right, these here are about 17 cents. It's 16 and a half cents per pen versus the ones on top that were 8 cents per pen, right? So obviously the top one is a better deal, but remember, price isn't always the thing that's most important, because you might say, Mr. Correa, why would I ever need 144 pens, right? You probably don't, so you might be more likely to get the smaller pack. But if you were a teacher like Mr. Correa, and you're used to just handing out stuff to students and then not turning them back, then you might want to go for the more pens for the cheaper amount of cost, right? So just a couple more examples for you guys to think about. So just the next time you're shopping for things, try to think about that, right? You might go to the supermarket, you might see that you can buy like, I don't know, a 3-liter of soda for a certain price. It might be cheaper to go with, 2 liters, depending on how much it costs, and you can do that math yourself. So just try to think about that the next time you're shopping for something online, the next time you go to the store. Okay, so we've got another example here. It says at the supermarket, Rix finds that 6 pounds of raisins cost $12. So what's the price per pound of raisins? Again, the way that we always do these is you're always going to take the cost divided by the number of things that you're buying. And the units in the question tell you what to do. So price per pound. So what we need to do is you just need to divide the price that's given, be careful with the order, divided by the number of pounds. So in this case, the number of pounds is 6, right? That's going to give you the answer there. I'm not going to do it for you. I want you to just do that simple calculation yourself. All right, so another example is when you have unit rates, and this is really similar to what we did with the push-ups before, is you can scale them up. So in this example here, it's telling us that somebody is going out to dinner. There's a special that costs $5, right? And apparently they're all going to get the same exact meal. That's got to be the best meal that they have at the restaurant, right? Otherwise they might order different things. And they're going together with 6 friends, right? So if they're all, again, very strange, getting the same exact special, and it costs $5 for one meal, you need to multiply by 6. And again, this is something that you can probably figure out without setting up this ratio, but it's more for when you get to harder stuff. That's why they're trying to give you an example like this, right? Because you might have harder examples later on where it says maybe it costs, $5 for 2 meals. If it costs $5 for 2 meals and they wanted to buy 6 specials, that ends up being a little bit different. You wouldn't just multiply it by 6. In that case, you would actually want to multiply it by 3 to get this 2 to turn into a 6. So that's something we're going to get into later, okay? And please let me know. I'm not getting too much feedback from people as I'm teaching, so I can't tell if I'm going too fast, if I'm going too slow, if we're understanding this stuff, right? Just as much feedback as you can give me, please let me know, right? Another good example is thinking about wages. So money, right? You guys are all going to be working soon. You're going to be making money. It's going to be useful to know how much money you're making per hour, and then to use that to figure out, okay, like, PlayStation 5 is coming out soon. How much money do I need to save up? How long is it going to take me to save up? How many hours do I need to work to make this if this is how much money I'm making, right? So that's how you can use math. And that's really what most people think when they think of math. They think about working with money, right? And you can definitely use ratios and rates to help you out with that. So if you know how much money somebody made in a week, right? Let's say you're working, you got a check at the end of the week, and you want to work backwards to figure out how much money did you actually make altogether, you can just use the number of hours that you worked. And again, it's almost always going to be cost or money divided by the number of things. So the person here in this example made $225. They worked 25 hours over the course of 1 week. So to figure it out, you would take $225 divided by how many hours you worked, which in this case tells us they made $9 per hour, right? If you're making $9 per hour, it's also good to know math because you're making less than minimum wage, and you should take that up with your employer because it's illegal, all right? Life lessons. Moving on. Next thing is talking about equivalent rates, and we also talked about this last week when we were talking about ratios, right? So sometimes you might see different fractions that are rates, and it asks you if they are in fact the same ratio or not. So you think about scaling up or scaling down, right? It's usually easier to think about scaling upwards. So in this example over here, we're comparing these two ratios. That's talking about the number of seats compared to rows in, say, a theater somewhere. So the first one, I'm comparing the ratio 24/3 to the ratio 8/1. And we're trying to say, are these two the same ratio? Again, I'm not sure why sometimes that kind of works, sometimes it doesn't. Just deal with me, please. If I want to see if these two are the same, remember we did something like this last week, it's usually going to be easier to think about scaling up from the smaller numbers to get to the bigger numbers. So I'm looking at this 8 compared to 24, the 1 compared to 3. So I want to think, can I scale this up? And it's really easy to check to see if that works out. So again, work from the small numbers first. Usually it's easier to work with the denominator. So to get from 1 to 3, and we work with multiplication. What would I have to multiply this by? It's simple. I would have to multiply that by 3. 1 times 3 gets me to 3. And then I check, okay, so does that also work up here? If I take 8 and I multiply 8 by 3, do I get 24? Yes, I do. 8 times 3 is 24. So these two are equivalent ratios, right? That's how you do those questions. You just try multiplying them together by the same number, the numerator and the denominator, to check and see if you get the same result. If you do not, then they are not going to be equivalent ratios, right? These tend to be the harder questions just because students sometimes get confused on what they have to do. Does anybody have any questions on this specific part before I move?
That I'm given a job in my life.
Okay, so almost done with the slides here, right? This is an example. Again, I don't want to do all the work for you, but I just help us to set it up, right? So it says that Deborah is traveling a distance of 2 miles in 1 minute. How much distance can she cover in 25 minutes, right? And people might think about these differently. There's different ways to answer them. Always start by setting up some ratios. So I can see here, these ratios are all in miles over minutes. So looking at this here, I can see that her ratio is 2 miles in 1 minute. So it's asking us how much can she travel in 25 minutes. So this ratio is going to turn into something, some number of miles divided by 25 minutes, right? So again, we always work with multiplication. So all you have to do is figure out 1 multiplied by what gives you 25, right? That should be a very simple question. And then you multiply 2 by that same exact number that you multiply by on the bottom to get to 25. That's going to give you your answer, right? Any questions on this part here? Again, I'm not hearing any. Okay, good. I see Logan writing in the chat. That's correct. Right, something else that we could do, right? I'll give you a different question. Let's say using this same rate of, 2 miles in 1 minute. Similar idea, let's say I wanted to know how long would it take for her to go, let's say, 30 miles. How long would that take? So again, I think about using the ratio. What do I multiply 2 by to get to 30? And somebody let me know. Okay, 15. 2 times 15 would give you 30. So I'd multiply this ratio by 15. I need to do the same thing with the denominator. So I would take 1, multiply it by 15. So it's going to take 15 minutes, right? That's how we use ratios to answer questions like this. And again, an example like this, if it's just talking about 1 minute, is usually not too hard. But the idea is once we start getting to other ratios that aren't unit rates, like if, say, it was 2 miles in 3 minutes, this is where the scaling up part becomes a whole lot more useful. Again, please let me know if you have questions so I can help you out with this stuff. Okay, no, not right now. Okay, so last thing is just the summary slide. I'll read this all together. It says, in this lesson, you learned about rates and unit rates. These quantity comparisons are similar to ratios. While a ratio is used to compare any two quantities, a rate is a type of ratio that compares two quantities that have different units of measure. So the main thing when we talk about rates is those different units. So like miles per hour, dollars per apple, dollars per diaper. When the units are different, we refer to it as a rate instead of a ratio, but it's really the same thing, right? It says rates appear in many everyday situations. You can use the concept of rate to calculate cost of food. So remember those examples I showed you on Amazon, looking at the pens or the diapers, everyday purchases. You can use rates to find the speed something travels if you know the distance traveled and the time it took. So remember, speed is always distance divided by time. If you forget that, just think miles per hour. Miles over hour, miles are a distance, hours is a time. So it's always distance over time. Unit rates are found by simplifying rates so that the second quantity is exactly 1, right? So if we knew that somebody did like 36 push-ups in 3 minutes, we would say, okay, so if I want to find the unit rate, that's how many they did in just 1 minute, right? Unit rates are used when referring to miles per hour, price per pound, and wages per hour. Remember that last one is just leaving off the 1. So it's like saying miles per 1 hour, price per 1 pound, wages per 1 hour. We just leave off the 1. When a rate is given as a ratio, it can be simplified to a unit rate. The rate and the unit rate are equivalent, meaning that they state the same comparison, right? So that was the end of the lesson, right? Again, ideally, you guys should have already done this on your own. I'm just kind of going over it, going over some key things, adding in some extra stuff in case we have questions, just to try to help with the knowledge sticking, right? So at this point, it is 9:20. We've got about another 10 minutes of live class left. If you have not already done so, you want to make sure that you start that mastery test today. You should definitely have enough